pentose phosphate pathway, it is divided into two stages. First stage is oxidative irreversible stage, followed by stage 2, which is non-oxidative pathway stage. There is a series of reversible reaction. This stage, it is oxidative stage, which produce two molecules of NADPH. The importance of the NADPH, it is used for the synthesis of fat, fat biomolecule, and also for the synthesis of steroid hormones. As you know, steroid hormones, it is derived from the cholesterol. Cholesterol is considered as the precursor for the steroid hormone. So, pentose phosphate pathway is active in adipose tissue, active in adrenal cortex for the synthesis steroid hormone, cortisol, and also it is active in testes to produce testosterone. It is active in ovary to produce estrogen, but it is not active in the skeletal muscles. As well as NADPH, it is used to maintain the integrity of the RBC. As the second stage of the pentose phosphate pathway, this is the second stage, which is oxidative stage, first stage, which is start from the glucose 6-phosphate, and then by the action of glucose 6-phosphate dehydrogenase, converted glucose 6-phosphate to the 6-phosphogluconolactone, and then need NADP and production of NADPH. As you know, glucose 6-phosphate dehydrogenase needs manganese, magnesium, and or calcium as a cofactor. 6-phosphogluconolactone converted to the 6-phosphogluconate by the action of the gluconolactonase need water molecule to hydrolyze the ring structure, and then 6-phosphogluconolactone converted to the ribulose 5-phosphate by the action of the enzyme 6-phosphogluconate dehydrogenase. This enzyme and also this reaction needs NADPH and libration NADPH. The first step and the third step are considered rate limiting steps reactions. This is non-oxidative stage. The second stage, it is known as a non-oxidative stage of the pentose phosphate pathway. This stage starts from the ribulose 5-phosphate by the action of the enzyme isomerase converted to the ribose 5-phosphate. This compound ribose 5-phosphate utilized for the synthesis DNA, as well as ribulose 5-phosphate converted to the xylose 5-phosphate by the action of the enzyme epimerase. And then after that, condensation, two types of sugar, ribose 5-phosphate, 5 carbon atom, with xylulose 5-phosphate, 5 carbon atom, and by this condensation catalyzed by the enzyme transketolase. Condensation and separation into two molecules, glyceraldehyde 3-phosphate, pseudoheptulose 7-phosphate. Glyceraldehyde enter the glycolysis pathway, and then, as I mentioned before, transketolase enzyme need thiamine pyrophosphate as a cofactor. After that, condensation glyceraldehyde 3-phosphate with pseudoheptulose 7-phosphate This step catalyzed by transaldolase enzyme, condensation and splitting to the fructose 6-phosphate and erythrose 5-phosphate, fructose 6-phosphate interglycolysis pathway. After that, condensation 4 carbon atom erythrose 5-phosphate with erythrose 4-phosphate, with xylulose 5-phosphate. This is formation 9 carbon atom, condensation and splitting into 2 compound, fructose 6-phosphate, glyceraldehyde 3-phosphate. So pentose sugar can enter the glycolysis pathway through formation of fructose 6-phosphate and glyceraldehyde 3-phosphate. So pentose phosphate pathway is considered as indirect way to produce ATP through the precipitation fructose 6-phosphate, glyceraldehyde 3-phosphate through the glycolysis pathway.